Good morning. Our next speaker is, or our first speaker of the morning here, has, we've told, crossed the country by motorcycle, train, plane, automobile, perhaps walked, perhaps dog sled, but nonetheless, he's here to take us to go with the flow through visual programming. Please welcome Mr. Adam Krebs.
Good morning. How's everyone? Thanks for putting my talk on. I built a data flow / flow-based visual programming language for solving the problem of long-tail configuration. I want to talk you through my journey of how I got here and why you might or might not want to build your own. So if you had a curve, this is the year of Vibe code. But Vibes are hard to steer. So programming is often about finding the balance between expressivity and clarity, between abstraction and probability. So to quote Rick Hector, by the way, Mike Bostock, programming is blinding and manipulating symbols. So blinding because we can't actually see the picture that we're drawing with our code, and we need to imagine it in our head. And manipulating symbols because we're not directly working on the output, we're working on abstraction. Right? Conversely, we're programmers. We hate UIs. They're limiting and infantilizing, and they don't compose easily. To make things simpler to understand, we've removed abstraction and had affordances that make a few tasks easier and others much, much harder. So why can't I just do the thing that I want to do? Okay, so I like this quote from Donald Clever, the AHL, and I think it encapsulates this kind of work pretty well. Being able to present dramatically different options and make quick decisions without regret is incredibly important to create. We want the ability to fail fast and not get too attached to one particular direction, but we also want to be able to steer the result with fine tooth. So bring it into code. In some ways, you could think about a text editor as a 1D infinite canvas. And it's like you're looking through this little window into a one-dimensional view of the code. If you are used to a mini map, I think that's kind of a similar concept.
In some ways, you can only ever see what's on your screen, and you're implicitly tracking the references to your symbols in other parts of the text to understand the data flow. Languages with S expressions are really good at this kind of thing. They're bad at others, but for tracking data flow, they work really well. We read code linearly, but that's really not how we think about relationships between objects in the system. And in fact, it's really not how the compiler operates on these relationships with an AST or a parse tree either. We want to think about our program structure as a grammar, understanding the nouns and the verbs and the links between symbols. In this way, text is just a terser representation of this concept. So this is a visual scripting language that I've been working on, specifically targeting geospatial and animations at this point. Don't get too hung up on that. I'm going to talk more generally about this, and I'll come back to this in a second. This talk is broken up into 3 sections. So first we'll talk about real-time feedback loops using data reactivity and why it's such a good fit for this kind of programming. Then we'll get into the framework. And then I want to talk about visual programming languages more generally and how this all fits in with some of the larger trends in programming. Okay, hi, I'm Adam. I'm from Joby Aviation. My background is in computer science. I was at Uber for many years, and now I'm at a spin out of Uber that's building an electric air taxi. So I want to acknowledge my colleague Chris Gervang here, who's been the main other collaborator on this project and a major part of its success. And I want to acknowledge my other Uber visualization colleagues who built a lot of the underlying frameworks for this. So I didn't start with wanting to build a visual programming language, and I had heard awful things about them over the years. But as I kept iterating through these problems, it kept poking me in the back of the head. So this is our aircraft. It's an all-electric vertical takeoff and landing vehicle that you request similar to an Uber. My job involves telling stories with maps and data and helping people understand the problem it aims to solve and how we're different than maybe what they're used to or what they've seen before. So in New York City, 29 million trips happen every single day in a taxi, right? And so at Uber, our vision is to alleviate this in the 3rd dimension. And this is basically talking through our demand maps and understanding where we can build routes of where our aircraft might fly. And we're using data to drive this animation, just using maps and available data. We tend to display these visuals on this giant 25-foot screen that we call the Jobytron at things like our launch events. So as visualizers, our mission is to foster trust and credibility through data and show how the aircraft interacts with the real world. Most people hate how much noise pollution helicopters generate. Since we're all electric, we're essentially silent flying overhead. We worked with NASA to compute an acoustic model of our aircraft and other light helicopters. And with this animation, we're kind of showing the difference. So it's all data-driven, but we've got these nice features like being able to zoom the camera. We've got 3D tiles, things that would be harder to do in a more traditional kind of programming application. And we have a long tail of a lot of these kind of projects. So dashboarding, interactive exploration, simulation, signal strength, route maps. Iteration is key, and our work is never truly finished. We just run out of time. But most of this work tends to follow a pretty common process where we start with some data set, process it through some intermediate steps. Maybe there's a difference of those intermediate steps. Maybe they're pretty closely related, and then we get some output, right? But we need the ability to modularize and make this repeatable, right? So we call it nodes. It's a way to visually program in the browser, and I want to talk you through what we built and what decisions were made. This is an operator. It's got inputs on the left, outputs on the right, and UI for the inputs on the operator itself are based on the field type. It's a 2D infinite canvas, so you kind of zoom around, and you can right-click and add these operators. The outputs and inputs are color-coded, which give you a hint. And we've got dozens of these operators that all perform one specific task. Now, the nice thing is that you can wire these up to multiple inputs and outputs, and you can kind of share these data types. It's a visual representation of, say, a pointer, right? But also, when this upstream updates, the downstream gets the value. Data is reactive, and the fields are strongly typed. Downstream operators run when the upstream data changes. So in this example, we're mapping mouse position to lat long on the screen. And we can see what's happening in any node with this viewer operator. And interactivity can be tough with these kind of applications. However, we've already solved the problem of interactivity with monads, right? So we're just passing it through these intermediate steps, and then we get this nice representation of where our mouse is on the screen output. Another thing to keep in mind is that this data is arbitrary. It could be a mouse position, it could be a stream of GPS points, it could be a CSV. The really nice thing is that I can set up this process where all the downstream follows that same intermediate logic, and then I just drag a new update, and everything downstream updates, which is really, really powerful. It's also GPU accelerated, so here's an example of 100,000 taxi trips in New York City, and I've got this great interaction where I can brush over and filter what's under the mouse. It's the kind of interaction that would be really, really tough to do in a text-based language, but becomes basically trivial in with a UI, right? And with some sort of fuzzy input. And so we've got a few high-level primitives, but for domain-specific tasks, I want a domain-specific interface. So in this case, we've got these geocoders where you type in a point, it'll give you a geopoint, a lat-long position. I can then feed it into this directions operator and choose between transit or driving directions, right? And what this really enables, and then this trips layer takes that line string and renders it to the map. But I'm not really thinking about the relationship between, or I'm not thinking about the specifics of the data type. I can arbitrarily remix this grammar, and it'd be the kind of thing that would be really hard to design a general purpose UI for. Like maybe I don't need this route for this particular visual, but I can drag and drop these in and start to compose these. So I think about it a bit like splitting the signal. So as long as the upstream data shares a similar data shape, all the downstream logic runs the same way. So one of these files is Abu Dhabi, Skyports, and the others in New York. But all the logic runs the exact same way between them, right? You know, it's just shared throughout. But I can also use, I don't know if you can see, but the second column over is the switch operator, and it allows me to switch arbitrarily between points. I think about it a bit like the select monad, where you've got a list of options, and then using some score, you decide which one to use. But I can still take that original file, I can do something with it, and come back to it. So for instance, let's say I wanted to add labels. I can just drag in this data and the position, drag it into a layer, and then using this concept of an accessor, I can grab the name property, and just like that, I have labels, right? Now, some of these label names are really long, so I can drag it into this other UI of a table editor, and now as I'm live editing this, the labels are updating, right? But again, I still have access to that original data field. I can add this offset column, and right now it's just JSON, but you know, we might make this friendlier in the future. I drag this in, and then I have the ability to go in and edit these attributes and nudge them around the screen so I can figure out where I want to place my labels. And again, this is the kind of thing that's really, really tedious to do, even if you have like live reloading, even if you have a nice text-based editor, it becomes more tedious the more complicated your composition becomes, or the more things are going on, right? Another major use case we want to support is animation. And here's a slightly more advanced example, right? So we have you know, these points, and I'm just setting keyframes. I'm like moving this playhead back and forth. And just like that, these values are updating. And any of these properties are keyframeable. So let's say I want to take the camera and the pitch control, right? And so I set a begin position and an end, or any arbitrary thing in the middle. And just like that, I'm getting these really powerful animation primitives. So I don't want to get too hung up on the geospatial examples. If you're interested, I gave a longer talk on this last year. But I just want you to notice that the accessors are lazily evaluated, so you can run them through intermediate transformations. The other nice thing is that I'm not really thinking about callbacks. I'm not thinking about list comprehensions or the specifics of the data type. You know, it handles polymorphism for me. I can drag one data type to another as long as they're pretty much compatible, and it'll make it work. Or I get an error if it doesn't, and it blocks downstream execution. So every frame in these videos that I rendered earlier is a composition of individual deterministic steps, and the timeline becomes just another signal passed into the system. So data visualization is this really great combination of, say, GPU shaders on one hand and SQL on the other. At the core, they're both declarative languages, so they're easily parameterized, which makes this kind of exploration really, really straightforward, right? So given keyframes and time, the framework interpolates the values that we use to construct state, and then the state to construct the frame, running through the intermediate transforms, things like filters, groups, or APIs. Everything's strongly typed, and we're using Zod in order to paper over some of JS's more fun type conversions. But it gives us discriminated unions, transforms, and structural types, which helps make the system a little bit nicer to work with. So this style is called flow-based programming. You treat your code and design as a DAG of black box operations using composition and message passing to get a final output at the end. These black box processes can be reconnected endlessly to form different applications without having to be changed internally, and so it's necessarily component-oriented. Okay. A couple of the design goals is more powerful types, focus on high-level abstractions, and then this REPL-style execution. And just FYI, this is I took this on Sunday. It's beautiful. If you can get out to Rocky Mountain National Park, highly recommend it. And all with the goal of kind of faster iteration. So it can be helpful to think about these as a projection between states and types. So in category theory, a morphism is a relationship between two objects. In the context of visual programming, you can think about these as the data structure types, and the arrows represent the functions that transform data from one type to another, and we're basically doing FRP here. So I'm not going to get into all these, so if you're watching later, you can pause the video and I'll link out to the slides. I mostly want to talk about concurrency and thinking about the program as a DAG. But nodes and VPLs can behave like multiple concepts at once. Since fields themselves can be composed to form operators, we have a lot of flexibility in how to create transformations to build more complex pipelines. The output of one morphism naturally flows as input to the next. So what is this thing? I call it a programming language because I interact with it the same way I do with a text-based language, but really it's a tight integration of the language with the editor, interpreter, and debugger into a single unified dev tool. Okay, so this is sort of like visual scripting or tool building. The ability to create small programs with arbitrary inputs visually lets us make changes really quickly. So something that's become really popular is these diffusion models, and there's a number of these workflow builders that allow you to, so this one's called Comfy UI, it's web-based, and there's an enormous community of people who are creating and sharing these workflows, essentially packaging the steps they took. There are workflows for slow motion, for up-resing videos, or for turning your dog into stained glass. But you can take these prompts and understand something about the system without getting too deep into how a diffusion model works, right? You can just change these parameters. So I think about it a bit like a recipe. Like maybe you want to swap out the pork for the tofu or something, and the rest of the recipe remains the same, but you can do that at, kind of at the start. So we're still very much in early development. Some things aren't fully built out. Some of the ergonomics aren't there, but there's some things that we can borrow from existing tools. And notably, I'm a programmer. I don't want to do all programming in nodes. I want a first-class programming environment. So I also want good tools that help me get to the results faster. In these cases, we have a code editor that we can use, and since it's 2025, it has to have Copilot. So it makes it really nice for editing lists of things. You can add in JSON, and just like that, I can build on these initial things. There's also DuckDB as kind of a core of this app as well, and ideally I want to move to a world in which DuckDB handles most of these things because we've got relational algebra through the whole thing. We have the ability to reference other operators with a mustache syntax, and it'll automatically update, let's say, these code operators here. This is just EV charging points. And also, we can switch between layers with this index here as well. The point isn't to replace bespoke apps or even notebooks, but offer a new paradigm for creating reactive apps quickly and testing ideas. So I had always heard visual programming languages don't work, that anytime you want to do something complex, they break down. And yet, people keep making amazingly complex projects with them, going much further than using text alone. So how many of you have used Blender? Cool, a lot of you. So, or how many have used a VPL before at all? Cool. So Blender has a shader graph, it has geometry nodes, it has a node-based compositor. It's got all these things that make it really, really simple. Like, sure, you could write out your shaders by hand, but there's something of just dropping in a node and getting an output, generally what you want. Also, if you've ever seen a building with lots of repeating patterns, it was probably built using something like Rhino Grasshopper, which is this lower left here. It's used in a lot of 3D architecture, simulations, that sort of thing. Houdini is the godfather of these tools. It's used in every Hollywood movie, water simulations, fire, pyro, and there's a tool called TouchDesigner, which is started by the same people. And I got to meet the creator of both of these tools a couple weeks ago just by accident, and it was pretty cool. But a lot of synths, a lot of compositing for Hollywood things, any concert visual, or lots of CI and CD pipelines. You know, you may have the artifact as a YAML file, but you can represent it either visually or as this YAML file. And you know, there's a really easy transformation back and forth between these two. So it's very fluid to use. I imagine it like a visual debugger of your call tree, the results of calling each operation as you go to the next. So you can see what happens with each one of these passes. You might hold out something, bring it back later, et cetera. Right? They're also really good for defining particle systems. So one of my projects last year was to bring our aircraft into Microsoft Flight Simulator. So if you have the game, you can go and fly. It's kind of fun. And for Christmas, or the holidays, we released this fun little Santa sleigh version. And the idea was brought to me that they wanted it to shoot stars out the back. And I was like, I don't even know if that's possible. Turns out there's a visual programming language built into Microsoft Flight Simulator that lets you emit particles, and so just like that. And I'm messing with the Bezier curve here on the shape of these particles, and that's also a common feature of these languages. So it's kind of these really nice UI controls that are simple abstraction primitives that you can use in lots of different places, but you drop it in wherever you want. So let's say, shape over time, right? So if you're sensing a pattern in these examples, they all benefit from immediate feedback. All are generally constrained data types with paired, constrained domains with pared down data types. And you interact by changing parameters and building workflows. They're pro-level tools, or at least for advanced beginners. And in almost all cases, they have an existing scripting language, but the environment is designed around enhancing that language. So good candidates are places where you'd have a domain-specific problem with strong associated types that can directly map to a declarative language, like SQL or shaders. And they tend to be good for large problem spaces. So there's a long tail of potential use cases, and they're really good for this kind of exploratory data analysis. So I kept coming back to this question, if VPLs don't work, why are there so many of them? And what I came up with is sometimes less is better. The complexity that helps with expressiveness in many text languages can be less relevant in a visual language with fewer abstractions. So I'm reminded by this factoid about, I hope I'm pronouncing this correctly, Bahasa Indonesia, which is the Indonesian language. It has only one tense, no grammatical genders, and no conjugations. It is also the 9th most popular language in the world. So often one way or the other isn't better, it just is. Different languages accomplish different goals or assist some ways of thinking. And I want to do a series of hot takes. So I believe that tools are a creative medium. They're vital to how we communicate and disseminate ideas. My background is in computer science, and I grew up believing that the command line was superior for every task. Most UIs are limited because they too are leaky abstractions. The problem isn't abstraction, it's leaky abstraction or bad primitives. And bespoke graphical UIs are often bad primitives because they don't model what the system is doing under the hood very well. In an attempt to be helpful to novice users, they often hide the complexity and also the power of the interface. On the flip side, it can be hard to use a text-only language with visual or complex data, and they're intimidating to a lot of folks. They can be a barrier to otherwise curious users to engaging further. Right? Immediate visual feedback is key in so many fields where you want these kind of fuzzy selections. So I wouldn't really want to edit a photo in code. You can write shaders, sure, but that sounds really awful. But I wouldn't want to script Photoshop either. That sounds miserable. So this edit, compile, rerun loop is just too tedious for these types of tasks, but a graphical UI is great for these kind of things. So bringing it back to Brett Victor and explorable explorations, I want to directly manipulate the program to really understand what's happening. And I want to treat my creative projects like Unix pipelines, individual actions composed to a larger workflow. I can then layer domain-specific tools in the middle of each process and build the actions that I want that work without switching tools. So as I've gone up and down the ladder of abstraction, I've used compilers, REPLs, and notebooks, even an oscilloscope or two. And even for these projects, we initially started with these kind of bespoke apps, then notebooks, then dynamic parameter interfaces like .GUI or Leva, and separate config file schemas. These all fell short because they can't encode arbitrary program structure. So your logic is strongly tied to the config schema and vice versa. It makes it hard to test values, it makes your code ugly, and so on. And remember, code is data. So I think that flow-based programming should be used in more places. I think it's often sold as this general purpose visual scripting, a way for non-technical users to understand programming, but it doesn't work. It's actually the right paradigm in a lot of places, and it should be used in more domain-specific applications. I don't see it as a replacement, but rather another tool in the toolbox that works really well for a lot of specific purposes. And it's also really hard to learn both a new language and a new paradigm at the same time. It's easier for someone to learn from examples or mapping their previous experiences onto a new problem space than it is to learn a completely new paradigm. So lastly, in the hot takes, if I'd like to make the argument that the best UI for anything that could be represented as a declarative language can and maybe should be represented as a VPL. Okay, so how does it feel to use? It's a bit like using a synthesizer. So it allows you to look at the program structure holistically as well as break things apart, make edits, drag things in, and you don't have to, you have a lot of flexibility. So Stephen Tanimoto called this liveliness. How responsive is the environment as you hotwire it like a circuit? So as a programmer, your goal becomes orchestrating the data flow, and I think about how objects relate. It's not a new idea. Here are two from over 50 years ago. Ivan Sutherland created Scratchpad in the 60s, and I have to imagine they were influenced by electrical diagrams. So where does this idea come from that they don't work? They're associated with kids and first-time learners. They're sold as an easier replacement for scripting, and they're not as expressive as text. Many of the features we get for free as text-first programmers are a lot more difficult in a VPL. It's called the scaling up problem, and it's why we historically haven't seen many of these large problems solved in a VPL. But the majority of these issues can be overcome with some design thinking or by throwing compute at the problem. And Moore's law has helped us a bunch here, and it's why I believe we're seeing more of a resurgence recently. So for instance, diffing, you just need more powerful tools or even a textual representation. So I want to kind of wrap up with this point, which is that I think that a number of silver bullets have been promised over the years, everything from COBOL and SQL to form builders, Ask Jeeves, Clippy, and LLMs. And I think each one of those has a nugget of a good idea. They're often sold as a way to replace programmers. It's not that easy to get rid of us. I think that continue building things that benefit from deep domain expertise, but also we can continue to make tools that are flexible. There are lots of these libraries for your own apps. I like this one. I think this is very cute. This is like, they're like holding hands and smiling. You can look into this. And my plea to you is this: check out a VPL. They've come a long way in the last few years, and they're really, really good fits for certain domains. I'd also plead for devs to stop trying to create a general purpose VPL. And finally, a language is only as good as its environment. Let's invest more in environments and encourage a hybrid of modules and libraries for performance-intensive code and a VPL for domain-specific operations. Thank you.
I think you've been racing across the country. But thank you very much. We have hit the end of our time, so if you have questions for Adam, please catch him in the hallway or talk with him. Or, you'll be able to see the talk also online. So thank you very much. And again, thank you. Another round of applause for Adam Krebs.